Hello, I am Hilary Lee, and today I will be presenting to you photonic crystals. So, what are photonic crystals? Well, many people haven't even heard of what photonic crystals are, but like other crystals, they do have a structure. Photonic crystals can be best described as periodical optical nanostructures that affect the motion of photons in much the same way as ionic lattices affect electrons in solids. Photonic crystals and color. Photonic crystals for the respective section of the spectrum, they would naturally need to have repeating units in order of lengths to have meaningful interaction. This is important to their connection to the electromagnetic spectrum because it contains range of wavelengths that are much smaller. There was an experiment done at the Georgia Institute of Technology in Atlanta that used different clippings of butterfly wings to understand how they got their color. And when they went under the microscope, they found that there was different little spaces in the holes in their wings that reflected different colors. And when they went under the electron microscope, they dropped different parts of isopropyl under the wing and noticed that they lose their color in the gaps of the nanostructures on the flat surface of their wing, and then it would evaporate and the color would come back. And this could be found in nature, and they could understand better how the color worked with the wings of the butterflies and how this could be seen in the crystalline structure of the photonic crystals. So the photonic crystals reflect certain wavelengths and let other wavelengths pass through. This allows them to appear a specific color that corresponds to the reflected wavelength. The energy that associates the certain wavelength that is prevented from being propagated through the crystal is defined as the photonic band gap. Well, the band gap can be defined as the crystal that has a complete photonic band gap if for some frequency range, the photonic crystal prohibits the propagation of electromagnetic waves of any polarization traveling in any direction from any source. How does this play into our lives? The photonic crystals can be applied in 1 dimension, 2 dimensions, and 3 dimensions. In 1 dimension, it's laid out more flat. In 2 dimensions, it has an overlapping grid. It looks more of a honeycomb shape. This can be used in more fibers, and in the 3-dimensional, it looks more like wood sticks overlapping and weaving into each other. So these can be used more in practical things that we use in our everyday lives and new inventions that we're still creating today and things for the future. In 1-dimensional photonic crystals, they're more flat. So you'll see them more in things such as lenses. Look at the example of the girl with the glasses on. With the AR coatings, you can see that the first picture they're more hazed over, and the second one they're more clear. That's due to photonic crystals to make them more clear for her. These can also be used in other lenses, such as cameras, to make them more clear and they won't get hazed over due to weather conditions too. 2-dimensional photonic crystals, they're a crystal optical fiber. They have a packing like honeycomb, such as the picture in the bottom right-hand corner. They can move towards quantum computers in the future, and they're used in incandescent bulbs. Photonic crystal coatings on incandescent light bulbs. This was discovered by scientists at Purdue and MIT. They learned that it bounces back the infrared back towards the filament and lets only light escape out. This increases the efficiency of the bulbs by several folds of 40%. Here's an example of a graph compared to an incandescent bulb and the human eye sensitivity in the visible range and wavelengths. In conclusion, photonic crystals are periodical optical nanostructures that affect the motion of photons in much the way of lattices affect the electrons in solids. They can be used in 1 dimension, 2 dimension, and 3 dimensions in technology and different objects that are useful, such as the coatings of glasses, camera lenses, to make things clearer, and incandescent bulbs to save more energy. Photonic crystals can be used wherever light can be manipulated. These are useful for everyday life, for things such as fibers in our lenses, and things that have yet to be discovered, and things that scientists are working on. These are used to also conserve our energy as well. Things that are all around us, the structures, and light.